Hello and welcome again to Higher Maths Differentiation. This time we are looking at equations of tangents. So as we already know, the gradient of a straight line is constant, so the gradient does not change on a straight line, which is why it is straight, because the gradient is the same all the way up and down that line. We can determine the gradient of a curve at a particular point by considering the straight line which touches the curve at that point. So this straight line that's touching the curve here is called a tangent. The gradient of the tangent to a curve y equals f of x at the point x equals a is given by f dashed of a. So if we want the gradient when x equals 5, we would differentiate and substitute in 5. If we want the gradient when x equals -2, we differentiate and substitute in x equals -2. So this is the same as finding the rate of change of f at a, which we looked at in the previous video. And then I'll tell you what, we'll just go straight into the example, guys, because I cover all of these points as part of the example here. So example number 1, find the equation of this curve at the point 2, 1. Right, first of all, we're going to draw what we're actually trying to do. So find the equation of the tangent to this curve y equals x squared minus 3 at the point 2, 1. So we know y equals x squared is a parabola that goes through 0, 0 and is concave up, or a smiley face parabola. So y equals x squared minus 3 will bring that parabola down and it will cross the y-axis at -3 rather than 0, 0. And we're finding the equation of the tangent to that curve at the point 2, 1. So here's 2, 1. I've drawn the tangent to the curve. Okay, so essentially here we are trying to find the equation of a straight line. So if our straight line knowledge is strong, that is going to be of great benefit to us here. So what do we need? We need a point on the line. So we've got the point 2, 1 already, and we need the gradient. How do we find the gradient? We differentiate it and substitute in the x-coordinate. So that's the first thing we're going to do. We're going to calculate the gradient. So dy dx will be 2x, because y equals x squared minus 3. So differentiate, we'll get 2x. Find dy dx when x equals 2. So dy dx of 2 equals 2 multiplied by 2, which is 4. So the gradient at this point is 4. That's what we've just calculated there. Now find the equation of the line. So we're going to use y minus b equals m bracket x minus a. So I've got the gradient of 4. I've got the point 2, 1. So a is 2, b is 1. So y minus 1 equals 4 bracket x minus 2. Expand our bracket, add 1 to both sides, y equals 4x minus 7. So it's a line with a gradient of 4 that crosses the y-axis at -7. And that is us. Find the equation of the tangent to the curve with the equation y equals x cubed minus 2x at the point where x equals -1. So this is a cubic curve that we'll see more of later on in this topic. But we're finding the equation of this tangent which is touching at -1, 1. So we are going to find the y-coordinate first in this example, because we didn't have it in the previous one. So to find the y-coordinate, we substitute the x-coordinate into y equals. So it'll be -1 cubed minus 2 times -1, which is 1. So our point is -1, 1. The next step we must do is find the gradient. How do we find the gradient? We differentiate. So dy dx would be 3x squared minus 2. Now, sometimes I get asked, Mr. Young, do you substitute in the x-coordinate or the y-coordinate? Well, it says here the gradient equals 3 multiplied by the x-coordinate squared minus 2. So it's the x-coordinate we substitute in. So it'll be the -1 that we substitute in. So 3 times -1 squared. So 3 times 1 minus 2 is 1. So we have a gradient of 1. We have the point -1, 1. So now it's just the equation of a straight line again. So substitute in the values. Remember, guys, a is the -1, b is the 1. So it's easy just to jumble these two up sometimes. Be very careful there. Multiply out the bracket, we're multiplying by 1, so we're just going to have x plus 1. So y minus 1 equals x plus 1, and add 1 to both sides, y equals x plus 2. So what do we need to do? We differentiate to find the gradient, substitute in the x-coordinate to find the gradient when x is -1, and then we're just using y minus b equals m bracket x minus a